Hey everyone, we're group 1 from 11A and today we're going to be explaining a past paper of Mathematics variant 9709, May June 2021, paper 51. My name is Adeline.
I'm Kimberly. And I'm Rochelle.
Yo, what's good? I'm Noah. I'll be the one editing the video later on.
So first, let's start with the first question. A bag contains 12 marbles, each of a different size. 8 of the marbles are red and 4 of the marbles are blue. How many different selections of 5 marbles contain at least 4 marbles of the same color? So as you can see, there are 3 possible combinations that we can do this. So we pick 4 red marbles out of 8 and 1 blue marbles out of 4. And the next one is picking 4 blue marbles out of all the 4 and 1 red marble out of 8 marbles. And lastly, we can pick 5 red marbles. So we can write this down as 8, we choose 4 of the red marbles, and we choose 1 of the blue marbles. So 8 choose 4 times 4 C1, which is 280. And next, we repeat the same thing. So 4 marbles out of the 4 blue marbles, so 4 C4 times 1 red marble and out of the 8. So 8 choose 1 equals to 8. And lastly, 8C5 because we choose all 5 marbles out of 8, which is 56. And you just need to add all of these numbers to get the final answer, which will equal to 344. So on to the second question. A company produces a particular type of metal rod. The lengths of these rods are normally distributed with mean 25.2 centimeters and standard deviation of 0.4 centimeters. A random sample of 500 of these rods is chosen. How many rods of the sample would you expect to have a length that is within 0.5 centimeter of the mean length? So since this is normal distribution, we can write this down as xn, 25.2, which is the mean, and 0.4 squared, which is the standard deviation. And since we have to find the length, which is within 0.5 centimeters of the mean, we can write this down as P 24.7, which is 0.5 less than 25.2, and 25.7, which is 0.5 more than 25.2. And we can use the formula, which is 24.7 minus the mean over the standard deviation, and the same for the other side. And then we can use the graph after we find the answer. So as you can see from the graph, 0 is the midpoint between this, and we have to find the probability of 0 to 1.25. And because of that, and you can see that this is symmetrical, so we multiply it by 2. So 2 multiplied by what you can find in the normal distribution graph, which is 0.8944 for the first possibility and 0.5 for the second one. And you can minus them together to find 0.7888. Looking back at the question, we can see that they have given us 500 samples of rods. So we multiply 500 with 0.788 to get the final answer, which is 394.4. Number 3A. How many different arrangements are there of 8 letters in the word release? So since there are 8 letters in total, we can write that as 8 factorials over the amount of e's. Since they're the same letter, we have to divide them by 3 factorials, so 3 e's, which will equal to 6,720. So letter B, how many different arrangements are there of 8 letters in the word release in which the letters LED appear in that order? So you can count LED as 1. So there leaves us 6 slots. So we can write that as 6 factorials. And there are 2 e's outside of LED, so 2 factorials. So we divide that to get 360. C, an arrangement of the 8 letters in the word release is chosen at random. Find the probability the letters A and D are not together. So as you can see, there are 6 ways to arrange the word RELESE, which you can write as 6 factorial over the 3 e's. 3 factorial equals to 120. 120, we can multiply that by the 7 slots. We pick 2 of the letters, so 7 permutation 2, which will equal to 5,040, which we will eventually divide by the number that we already found in A, which is the amount of times that release can be rearranged. So 6,720, so we divide 5,040 with 6,720, which is 0.75 or 3 over 4.
To number 4. Question 4. Let us see the problem that they have given us. To gain a place at a science college, students first have to pass a written test and then a practical test. Each student is allowed a maximum of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first attempt. No student is allowed more than 1 attempt at the practical test. If a student fails both attempts at the written test, then they cannot attempt the practical test. Draw a tree diagram to represent this information, showing the probabilities on the branches. Now let us see the statement that they have given us about the probabilities. The probability that a student will pass the written test in the first attempt is 0.8. As you can see, first written test attempt pass is 0.8. So what is the probability that the first written test they fail? It's just 1 minus 0.8, which is 0.2. If a student fails the first attempt at the written test, so this one, the probability that they will pass the second attempt is 0.6. So written test 2 pass is 0.6. So the probability of it failing is just 1 minus 0.6, which is 0.4. Next, the probability that a student will pass the practical test is always 0.3. This one cannot branch out anymore because it is written here that if a student fails both attempts of the written test, they cannot attempt the practical test. Now we only have two types of branching. Either they pass on the first attempt or they pass on the second attempt. If they pass on the first attempt, then the practical test passing chances are 0.3. It's always 0.3. So the failing chances is just 1 minus 0.3, which is 0.7. The same goes with the second attempt. 0.3 if you pass and 0.7 if you fail. And that's for number 4. Next question B. Find the probability that a randomly chosen student will succeed in gaining a place at the college. What is the statement and what is the requirements of gaining a place at college? From the question we can see they have to pass the written test and pass the practical test. If we see the tree diagram, which one they pass both exams, it's this one and this branching. So the first branch is they pass the first written test and then they pass the practical test. The second one is they fail the first, then they pass the second written test, and then they pass again for the practical test. So this would just be the first branching, which is probability of first written test times probability of passing the practical test, 0.8 times 0.3. Plus the second branch, which is the probability that they fail the first test, but then pass the second written test and then pass the practical test. It's just 0.2 times 0.6 times 0.3. Now, after we total them up, we get the result of 0.276. Moving on to letter 4C, find the probability that a randomly chosen student passes the written test at the first attempt, given that the student succeeds in gaining a place at the college. So probability first written test attempt pass over probability of gaining a place at college. So this means we need to see probability of passing the first written test and also intersecting with the probability of passing the practical test, which is just this one. So you pass the first test and then you also pass the second test. That would be 0.8 times 0.3 as written over here, divided by the probability of gaining a place at the college. Previously in B, we can find out that the probability of gaining a place in college is 0.276. So you just divide those numbers and the result will be 0.87. Now we're on to question number 5A. Draw the times taken by 200 players to solve a computer puzzle are summarized in the following table. A. Draw a histogram to represent this information. When they ask to draw a histogram, this means that they're asking for a frequency density table. Why? Because they have different ranges between the time. So in order to make a frequency density graph, you need to first find the class width. So the class width is just the largest number minus the smallest number. So we have 10 here, 10, 20, 20, 40. As you can see, the width of each range are different. Therefore, we are using frequency density graph. Frequency density is just the frequency or number of layers divided by the class width. So 16 divided by 10, 1.6, 54 divided by 10, 5.4, and so on and so forth. Now we just need to construct the graph and put in our values together, which will become like this. Five B. Calculate an estimate of mean time taken by these 200 players. In order to find the mean, we need to first find the mid value for each of these ranges. How do we find this mid value? So in order to find the mid value, we just need to add up the largest number with the smallest number divided by 2. So for example, this is 10 plus 0 divided by 2. So that means the mid value would be 5. After we find the mid value for all of these ranges, we just need to multiply each mid value to its respective frequency or number of players. So for example, the mid value of time is 5. We multiply this with 16. And we add all those product of the mid value with the number of players. Then we divide it with the total number of players, which is 200. So it becomes 6,430 divided by 200, which will make 32.15 as their mean. Now moving on to 5C. Find the greatest possible value of the interquartile range of these times. When we talk about interquartile range, we talk about the upper quartile minus the lower quartile. In order to find the lower quartile, we need to times 200 with 1 over 4. 200 is the total number of players. This will become 50. 50 here represents the first 50 people or the first 50 players. So to find the value for the lower quartile, we need to go back to the table and find the range that lies the first 50 people, the smallest range for it. So in here we see 16, the first 16 people. The first 50 people is more than the first 16 people. Therefore, it doesn't lie in this range. Now we go to the next range. The next range is 16, the first 16 people, with the next 54 people. This becomes 70. The first 50 people lies in between the range of the first 70 people because 50 is smaller than 70. Therefore, we can use this range for the lower quartile. If we go back to the question, it's asking us for the value. This means that we need to find the lowest value because it's the lower quartile, so we need to find the lowest value within the range. This is 10. Next is the upper quartile. The upper quartile is 3 over 4 times 200, which is 150. So from this is the first 70 plus 78, which is 148. So it doesn't lie in this range. 148 plus 32 is the first 180 people. So that means 150 lies in this range. Therefore, we can use this range. Because it's the upper quartile, so we need to find the upper or upmost value, which is 60. So the maximum is 60. Therefore, the quartile is just upper quartile 60 minus lower quartile 10, which becomes 50.
Number 6. In Cuesta, 60% of the adults travel to work by car. A random sample of 12 adults from Cuesta is taken. Find the probability that the number who travel to work by car is less than 10. For this number, we're going to use the binomial function, xb, open bracket, n, comma p. N is the total number of sample, and p is the probability of success. In this question, it is said to find the probability of number of adults who travel to work by car, which is less than 10. So we will use complement. You use the total probability, which is always 1, minus probability of 10, 11, and 12. For this number, we will be using the formula Px equals to the total sample combination x times the probability of success to the power of x times the probability of failure, which is 1 minus x to the power of the total sample minus x. Using this formula, we are able to find the probability of 10, 11, and 12 as written on the sheet. After you have find the probability of 10, 11, and 12, we use the complement and input it to the to the function that I've written on top, which is 1 minus probability 10, 11, and 12. And at the end, you'll get the final results of 0.917. Next, a random sample of 150 adults from Cuesta is taken. Use an approximation to find the probability that the number who travel to work by car is less than 81. For this number, we have to use the normal function, xn, open bracket, mean, comma, variance. In order to find the mean, we have to use the total sample number multiplied by the probability of success. And in order to find the variance, you have to use the total sample multiplied by the probability of success multiplied by the probability of failure. After I've calculated everything, we get that xn, open bracket, 90, 36, or 6 squared. 90 is the mean, and 36 is the variance. Meanwhile, the standard deviation is the square root of 36, which is 6. In this number, we asked to find the probability of x less than 81. And since they asked to use approximation, we have to minus 81 by 0.5. So, in order to find the probability of x less than 81, we have to find the probability of z less than 81 minus 0.5, which is 80.5, minus the mean, and then divided by the standard deviation. After calculating this, we get that the probability of z is less than negative 1.583. The probability of z being less than negative 1.583 equals to the probability of z less than 1.583 complement. And therefore, in order to find the probability of z being less than 1.583, you have to find 1 minus 0.9433. Where you get 0.9433 is from the normal distribution table. After calculation, we get that the probability of z being less than negative 1.583 equals to 0.0567. Number 7. Sharma knows that she has 3 tins of carrots, 2 tins of peas, and 2 tins of sweet corn in her cupboard. All the tins are the same shape and size, but the labels have all been removed, so Sharma does not know what each tin contains. Sharma wants carrots for her meal, and she starts opening the tins one at a time, chosen randomly, until she opens a tin of carrots. The random variable x is the number of tins that she needs to open. Show that the probability of trial she needs is 3, equals to 6 over 35. So first, we know that the total number of tins is 7. And to find the probability of tins containing carrots, it's the 3 tins of carrots over the total tins, which is 7. So probability of carrots equals to 3 over 7. Meanwhile, the probability of peas is 2 over 7, and the probability of sweet corn is 2 over 7. In order to find the probability of the trial equals to 3, you have to find the probability of not carrot times the probability of another not carrot times the probability of carrot. So to find the first probability, we know that there are 4 tins containing not carrot. So it will be 4 over the total numbers of tins, which is 4 over 7. In order to find the second probability, we know that there are only 3 tins that contains not carrot, and there are also only 6 total tins. Therefore, the second probability will be 3 over 6. Lastly, we have to find the probability of carrots. As we know, there are 3 tins of carrots, and the total number of tins is only 5. Therefore, we get that the probability of the tin containing carrot is 3 over 5. To find the probability that the total number of trials is 3, we'll multiply all of that. 4 over 7 times 3 over 6 times 3 over 5 will be equal to 6 over 5. Therefore, the probability of x equals to 3 is proven. Next, draw up the probability distribution table for x. As we know, it is stated that the random variable x is the number of tins that she needs to open. And in this case, there are 5 probabilities of x. X equals to 1, 2, 3, 4, and 5. First of all, you have to calculate the probability of x being each of them, 1, 2, 3, 4, and 5. And as you can see, I've done all the calculations for it. So after you've done all the calculations, a probability distribution table will be made. It is basically a table that shows the random variable and the probability for those random variable to happen. So we get the x, 1, 2, 3, 4, 5, and each of the probability. You get that x equals to 1, have the probability of 3 over 7, which is 15 over 35. X equals to 2, have the probability of 10 over 35. X equals to 3, have the probability of 6 over 35. X equals to 4 has the probability of 3 over 35. And lastly, x equals to 5 have the probability of 1 over 35. For the last number, 7c, we are asked to find the variance of x. In order to find this number, we have to find the mean of x first. The mean of x is basically the number x multiplied by its probability. And therefore, you have to multiply x equals to 1, 2, 3, 4, and 5 by each of their respective probabilities. As you can see, I've calculated every single one of them, and I get that if x equals to 1, it has a probability of 15 over 35. If x equals to 2, it has a probability of 20 over 35. X equals to 3 equals to 18 over 35. X equals to 4 equals to 12 over 35. And lastly, x equals to 5 is 5 over 35. And therefore, we get that the mean of x equals to 2. Next, in order to find its variance, it's basically each of the x squared multiplied by its probability. And as you can see, I've calculated each of them, and you get that x equals to 1 squared multiplied by 15 over 35, which is its probability is 15 over 35. X equals to 2 squared multiplied by its probability is 40 over 35. X equals to 3 squared multiplied by its probability is 54 over 35. X equals to 4 squared multiplied by its probability is 48 over 35. And lastly, x equals to 5 squared multiplied by its probability is 25 over 35. After that, you have to add them all up and then minus it by the mean squared. You get that the total is 182 over 35 minus 2 squared. And after you've calculated everything, you get that the final result is 6 over 5.
We will be explaining. Okay, I'm a bit pissed right now.
Gue lupa nama function.
Presentation ever.
Guys, I'll do it at home. Go on.
Tinggal satu letter.
Baby,